C is the language most systems software still runs on under the hood. This video walks level 1 of the C mastery path start to finish, variables and types, control flow, functions, pointers, and structs 5 lessons, 1 continuous arc. C makes you declare every variable's type up front, so the compiler knows exactly how many bytes to reserve. Let's look at core types, casting, and a wraparound bug every C programmer eventually meets. Here's a typical declaration: an int, a float, a double, a char, and 1 int declared but not yet assigned. Reading that last one before assigning it is undefined behavior. C won't zero it out for you. Exact sizes aren't guaranteed by the C standard, so instead of assuming, you ask with size of. On a typical 64-bit machine, an int is 4 bytes, a double is 8, and a char is always exactly 1. Divide 2 ints and C does integer division, silently dropping the fraction 7 divided by 2 gives you 3, not 3.5. Casting 1 operand to double first forces real, floating point math instead. C also has plain arithmetic and logical operators, plus, minus, times, integer divide, and modulo for arithmetic, greater than and equals for comparisons, producing 0 or 1, and for combining conditions logically. Add 1 to int_max and instead of an error, C silently wraps around to the most negative value an int can hold. It won't warn you at runtime, it just happens. With that lesson learned, let's look at how C makes decisions. With data in hand, a program needs to make decisions and repeat work. C's control flow looks familiar if you know a C family language, but one detail switch-fallthrough catches nearly everyone once. A straightforward if, else chain, C checks each condition top to bottom and runs the first true branch. A score of 72 skips the A and B checks and lands on C. Any non-zero value counts as true. A ternary is a compact if-else that produces a value in one line. A greater than B picks the larger of 2 numbers directly, without a separate variable assignment inside 2 branches. Here's the classic trap: switch falls through by default. Forget a break after case 1, and execution keeps running straight into case 2 as well, so n equal to 1 prints both 1 and 2, not just 1. For loops bundle setup, condition, and increment into a single line, which is why they're the default choice once you know how many times you need to iterate. This one just counts 0 through 4. Add break and continue for finer control. This loop stops entirely the moment I hits 5, and skips printing any even number along the way, leaving just 1 and 3 on screen. Decisions and loops sorted. Now let's package logic into functions. Every program past a few lines gets broken into functions. C draws a sharp line between declaring a function's shape and defining its body, a distinction that matters once code spans multiple files. A prototype like int add, int A, int B, tells the compiler a function exists before main calls it. The real definition can live anywhere after that, even in a different file, which is exactly what header files are for. Global variables are visible to every function in the file, which is convenient but risky. Any function can reach in and change them. Here increment_counter modifies a global directly, bumping it to 2 after 2 calls, while local stays private to main. This surprises people coming from other languages. C passes arguments by value. Increment gets a copy of x. It can print 6 inside its own scope, but back in main, x is still 5, completely untouched. Recursion works as you'd expect. Factorial calls itself with a smaller number each time until it hits the base case, n less than or equal to 1, which stops the chain and starts returning values back up. One C-specific trick: marking a local variable static means it keeps its value between calls instead of resetting. Call this function 3 times and the counter climbs 1, 2, 3, private to this one function. Next, pointers, which finally let a function modify the caller's variables directly. Pointers are what make C feel different from almost everything else, and they finally solve the pass-by-value limits from the last lesson. Every variable lives at an address, and a pointer just stores one of those addresses. The address of operator, an ampersand, gives you a variable's location instead of its value. Printing age normally gives you 30, printing ampersand age gives you the address where that 30 actually lives, shown with the %p specifier. An uninitialized pointer holds a garbage address, and dereferencing it is undefined behavior, a common source of crashes. Good practice: initialize a pointer to null when it points nowhere yet, and check before you ever dereference it. Declare a pointer with a type and a star, pointed at age's address, and *AgePTR lets you read or write age indirectly. Assign through the pointer and age itself changes. You just modified a variable without touching its name. Here's the payoff: pass addresses instead of values, and a function can finally modify the caller's variables. Swap takes pointers to x and y, dereferences them, and after the call, x and y have genuinely traded places back in main. One more piece clicks into place: an array name, in most expressions, decays into a pointer to its first element. That's why numbers and its first element's address print identically, and why square bracket indexing and pointer arithmetic mean the same thing under the hood. Next, we group related values together with structs. Last stop, structs, C's way of grouping related values into one custom type. If you've used a class in another language, a struct is the data half of that idea, with no methods attached. Defining struct point just describes a shape, it creates nothing yet. Struct point p1 actually creates a variable with that shape, and the dot operator reads and writes its members. You can also initialize the whole thing at once, like p2 equals 10, 20. Struct members can themselves be arrays or other structs. Here a student holds a fixed name array and a nested point for an office location, reached with a second dot. Notice the name field needs strcpy, not a direct equals sign. Writing struct point everywhere gets repetitive fast, so real C code almost always pairs an anonymous struct with typedef, giving you a clean standalone type name like point. No struct keyword required anywhere else. Just like arrays of int, you can have arrays of structs, perfect for managing a list of records like contacts or students. Here roster holds 3 student entries, each filled in with strcpy and a GPA, then printed in a loop. And structs inherit the same pass-by-value rule functions always had. Try to move receives a full copy of origin, moves it, and origin back in main never changes. For anything bigger than a couple of fields, you'd pass a pointer instead, the deliberate next step once you reach level 2. That's the arc: variables and types, control flow, functions, pointers, and structs, 5 modules that take you from a blank editor to writing your own custom data types in C. Every lesson has runnable exercises waiting at the links below, in the order we just covered.